You can tell me where to stand.
All right, we're good.
All right, Gianni, I forgot my stand that holds the camera. So we have the camera stacked up on
wobbly.
tissue boxes and globs of tissue. So if I go in and out of the picture, that should be fine. So we just reviewed, Gianni. First of all, where are you? So this is not a good start. So hope you're doing okay and be back here soon. We started reviewing, and I didn't record all the review. If you would open your comp book and look at the stuff we went over the last day we worked together, that would be helpful. And we jumped sort of down here for you, and we indicated 1/2 to the n generates this sequence. And then we came up with this one. I gave you this one, and we came up with this one. So we went both ways for practice. Now we're to something a little bit new. All right, I've been talking to you a little bit about sequences. Anytime I say series today, correct me. We're not into series yet, it's sequences. Every time we talked about sequence, we talked about whether it converged or diverged, and we did a couple of those before the end of the class last time. I want to give you a rigorous definition for the limit of a sequence. So let me, as I write it, dictate it, would you please write it down? And I'm going to leave out the last blank, because actually you have seen this definition before in another setting, and it's almost identical. So see if your conscience or subconscious can pull out the last little bit of it. So what are we defining? The limit, does this blue show up or should I switch?
It's good.
Limit of a sequence. So write that down and I will dictate it until the very last part. So what I am, this says limit of a sequence, so in Math Ease, it looks like this. The limit, as n approaches infinity, of a sub n equals L. So that's saying the same thing. The limit of the sequence. A sub n is our sequence. And recall, when we look at the limit, we're seeing whether it converges to a number or does not. And if it does not, we said it diverged. Well, this one converges to L if. So this is what we're learning today, the rigorous if. For any epsilon is that this direction? Oh, Greek students, okay, I keep making it like a 3. For any epsilon, no matter how small, I'm not going to say that, but they're generally, I'm not going to write that, I did say it. I'm not going to write no matter how small, but generally we're interested in the small ones, not the large ones, but it'll work for any epsilon. For any epsilon, there is an M, capital M, such that for little small m greater than big M, this will make more sense when I finish. Pull it all together. Are you getting it down? Limit of a sequence so far. The limit as n approaches infinity of the sequence a sub n is L if, for any epsilon, no matter how small, there is a big M such that for any little m greater than big M, so there's sort of a dividing line where this becomes true, and that dividing line is big M. So when we pass that, the difference, try to get a picture in your mind of what's going on. The difference between a sub n and L is less than blank. All right, just finish writing it down and see if you can fill in the blank. for the definition, the rigorous definition of a limit. Are we in? Okay. So the limit of a sequence is L if for any epsilon there is a big M such that for any little m greater than big M, the difference between A sub n and L is less than, what do you think?
Is it a number?
Is not, it is a representation of a number.
Infinity.
No,
Epsilon.
very good.
Nice, Aaron.
I kind of gave it away. Oops, almost wrote it the wrong way. I almost gave it away because I kept saying no matter how small. So, yes, between the difference between these two is less than epsilon. All right, it doesn't probably make a whole lot of sense until you see the picture of it. Does that look familiar at all?
Not really.
No? Okay. All right, well, we know that for some sequence, this is going out and maybe it's going like that. And so we might say the limit of the sequence is whatever this number is, L. So, how does this definition correspond to that picture? Well, the limit of that sequence is L if for any epsilon, so let's say the epsilon, we're going to pick an epsilon, any epsilon, I'll say 1/10. That's fairly small. There is an M, so the M looks like it's about here, such that for M greater than that, so we're going to be on this side, yeah, that's fine, since I won't be over here most of the class, but you can just tape it. So on this example, if I go past M, look what happens on this side of M. The difference between the sequence and L is getting smaller and smaller and smaller. So that is the limit if that's happening. So somewhere in there, right at, say at this point right here, maybe right here, maybe that difference is 1/10. If it's not, I have to move M down, but can you believe that there is a big M somewhere here where the difference between here and here is 1/10? What about if epsilon was 1/100th? Then M would just be further down here, and this is going to squeeze even closer. So if this is the limit for this function, this will always happen. So where have you heard this before? Should have been maybe, unless you did a bunch of calculus, pre-calculus review in your first day or week of calculus. This should have been in the very first day, week of calculus. It is the definition of a limit. And you learn derivatives as a limit before you learn them the quick way. So peek back there. Look on page, say, 52. Not in my book because I didn't teach you Calc 1, but in your book. Aaron, you have a book there. Look up in the beginning, page 52, and you'll see something that is strikingly similar to that. Page 52. All right, so look at that definition there. What is that? Do you see epsilons and things like that in it, Aaron?
No. Oh, yes.
Okay. They also have deltas. It works a little different for continuous functions. Ours is discrete, but it has a lot of the same things to it. So this should look somewhat familiar. It was way back though. All right. Let's go ahead then and go back to...
Tissue in it.
Let's go ahead and go back and see if you can tell me. This is more repeat. So you can write this one down.
Which file we're at? 9:18.
Okay. Probably we'll do this example then and we'll cut it off. This tells you the rigorous definition for a limit. So I'm going to give you one. You won't use this definition. This just solidifies what a limit is in your mind. I want you to see if you can find whether this sequence converges to a number, which we call the limit, and the sequence is b sub n. n is 1 minus 2 over n. So see if you can recall. I'll start us off, and the question is, does this converge? Does it converge? And if it does, you'll tell me what it converges to. If it does not, you'll tell me so. So, in order to do that, we decided to look what's happening way down the line when n is approaching infinity. So this is what, we pulled this out of our hat last time we met together. And we discussed, to answer that question, we just need to take the limit as n goes to infinity of that. So, see if you can recall how we could go about doing that. The limit as n approaches infinity on this one. Well, first thing you would do is just stick infinity in and see what happens. So, what happens on this particular one when we're sticking infinity in where n is? Aaron, what happens?
It would be infinity minus, over infinities.
Over what?
Infinity.
Well, we have a
Over
negative
0.
1 minus 2 times infinity,
Infinity.
which is basically what? Because of that minus, what happens on the denominator?
Negative.
Right, it is. So is that a candidate for L'Hopital? It is. Remember, there are only two candidates basically, 0 over 0 and some form of infinity over some form of infinity. So L'Hopital it and see what happens the next time. L for L'Hopital, not limit. So Brendan, what do we do with L'Hopital to this expression?
Take the derivative.
And what do we get on the top
1,
and the bottom?
-2.
All right, so Brendan, what's the limit of that as n approaches infinity?
-1/2.
Right. Does it converge, Brendan?
Yes.
It converges to -1/2, so. All right, does that bring it back where we were before? All right, try one more, and I'll put this one up and then you can turn off the video.
All right.
All right, and that will be, let me get rid of our rigorous definition here. Oops. Guess why you're not gonna need, it's not working right.
Yeah, it can't get the top when it's on the tissues. Aaron, you're messing up the video.
So awful.
All right,
You're such a...
see, so then,
You Derek, no! Not today.
all right. There's a thing you can sign, Jonathan, or not sign, and we're not allowed to put you on a video. All right, see if that one converges or not. Gianni, give it a try, we'll catch you on part 2. How many?